So we're in section 3 of chapter 9 today, talking about a different type of transformation. So recall transformation. And we had our Darth Vader out here, who is also a, what do you call that little kind of thing that Darth Vader flew? Well, no, the whole thing's a transformer, but it was a fighter, TIE fighter, right? Transforming simply means to take some figure and change it into the image of itself somehow. There are many transformations. Today we're talking about reflections. That is a type of transformation. So when you think of the word reflection, where do you see reflections most commonly, Hannah?
Mirror.
A mirror. So a mirror image, right? A mirror image. So here's an example of reflection in use in the real world, which is kind of an interesting one. Have you ever seen this? Who has seen, oh, you're frozen, sorry. Who has seen this? Do you see what's going on here? What is interesting about the front of this vehicle here? Braden. It's ambulance. It's an ambulance. We all see that. And it has ambulance not just backwards. I mean, look at the L is like facing absolutely differently, isn't it? And so why do they put words like this on the front of an ambulance, Dylan? Something above? If I look down on it, do I see ambulance? Wesley? That's exactly why, right? If you're in a car in front of this, which hopefully you're not coming straight at it, right? You're instead in front of it, maybe you're at a stoplight or something, and you look in your rearview mirror. That's what drivers do to see what's going on around them, right? And they immediately can read what word? Ambulance, because they're using their mirror. The absolute mirror reflection of this is the correct word, ambulance. And so when somebody looks in their rearview mirror and reads ambulance, they don't even think about the fact that that word has been put there in a reflected way so that they can see it, you know? They just see the word ambulance, and maybe they need to get out of the way, right? Okay, so reflections, mirror images. We have different ways that we can reflect things. Let's see if we can identify a reflection. These two figures, I've placed a line between them. We could call this a line of reflection. So are these two images reflections of each other? Thumbs up if you think they are. Do they reflect? They do, good. And so how can you tell? I mean, how can you define this for someone who doesn't know what a reflection is? Most people do, right? But how can we define this mathematically? Liam?
Well, if you flipped it the other way, it would match.
It would match. So he says if you were to like fold this, if it was a piece of paper and you folded it, would everything land on top of itself? I mean, would the figure be on top of itself? Yes. Very good. Kind of like our hands. When we clap them together, the thumbs are matching the thumbs, right? But they are different, aren't they? They're facing different ways on our bodies, right? Another way to think of it is how far away from the line of reflection is this point and this point? When you compare how far away from this line they are, right? What can you say about those two distances? They are equal, right? They're the same distance from some line of reflection, and that is what takes place with reflecting across lines. Okay, all the points are the same distance from the line of reflection. So how about this? Could we put a line of reflection, could we configure a line of reflection somehow between these two figures? What do you think? Casey, you're saying no? And why is that? What about this way, like between? Could we make it happen that way? Let me grab a line of some kind here. Could we put one here? Does that work? When it comes to line of reflections, you're right, that doesn't work because if we just take, let's say, this point here and go straight to the line, okay, we could travel about that same distance this way, and is there a matching point over there? No. So this doesn't have a line of reflection, okay?
Well, couldn't you just flip it?
If it was flipped, you might have a line of reflection. That's true. You know, as you get further into geometry, we find out that we don't only reflect things across lines. Watch this. We could put a point here, right? We could put a point. Now, if I was to measure the distance of any point to that point, and then across from it, now do I have a reflected point? Yes, right? Even this vertex here is about that far from this point, and so is the other vertex, right? So we could put a point of reflection here. This is a little bit of advanced geometry for you though, but there is no line of reflection for this figure. There is for the first figure. Okay, do you understand the difference between a point and a line? The goal today is to find the math behind reflecting things. And it's a very simple little math thing in order to reflect something. Okay, so we're going to have to draw a little coordinate plane. You might need to pause and do that. We also said that the line of reflection, each point in the reflection is the same distance from the line as its corresponding point in the original. So back to our example here. This point is the same distance from the line of reflection as its corresponding point in the image. Okay, so jot that down. Okay, we're going to reflect 2 points here. Just points. And then later we'll reflect an entire figure. Okay? So reflecting point K, we want to do point K in the y-axis. We're going to reflect it in the y-axis. So the first thing we might want to do is identify the location of point K. Where is point K? Faith, can you tell us? Good. Negative 10, 0. So if we're going to reflect that point in the y-axis, where will it end up? When it says in the axis, you could replace the word in with over, right? You're reflecting it over or across the y-axis. So where would it end up? Hannah? It would. And can you actually give me the location? Good job, 10, 0. So here would be the image, or K prime. It ends up at 10, 0. Very good. So when we look at the ordered pairs, we went from negative 10, 0 to 10, 0. What operation could we use to go from negative 10 to 10? You could add, you would have to add what? 20. Okay, but that wouldn't be necessarily true for another point. We wouldn't just add 20, right? What else could we do to change a negative 10 to a 10? Multiply by? What could you multiply by? By. Anyone? Wesley? He's saying negative 1. Do you see that? If you multiply the x value by negative 1, negative 10 times negative 1 is 10. And the y value just stayed the same. Okay? I know that's 0 is kind of not the best example, but if you're crossing the y-axis, you multiply the x coordinate by negative 1. This kind of reminds me of our special cases in graphing linear equations, remember? If you want to graph a horizontal line, who remembers the equation for a horizontal line? Would it be all the x values equal something or all the y values equal something? all the y values. It's opposite what you think. So if you want to cross the y-axis, change the x value to the opposite. That's what we just saw here. Let's try this with point P. But this time point P, we're going to reflect in the x-axis. So we have to name point P. Give me the location of point P. Isabella? Good, 3, 2. So point P is at 3, 2. And now we're reflecting in the x-axis. Again, you could use the word across. Reflect across the x-axis. So if we're just going to take point P across the x-axis, who can give us the coordinates of the new image? Can you do it, Liam? -3, -2 would be here, right? Now, did you just cross the x-axis? Or did you cross the x-axis and the y-axis? You did. You did more than we need. We only want to cross the x-axis, so can you try it again? Just the x. Here's the x-axis. Is that the x-axis you crossed? Very good. +3, -2. This way. So we now have 3, -2, and that is P prime. Okay, so when we cross the x-axis, which value changes? 3, 2, 1. No, not the x. The y. Look it. The x stayed the same. The x is still 3. It's the y value that is the opposite. And to find an opposite, you multiply by -1, right? So that's what we're doing. Multiply the y value by -1. Okay, so you will either have to be asked to reflect a point across an axis, right? And then you can go do it. Or someone might give you a picture, a graph like here, and say, whoops, oh, what am I doing here? Point P and P prime. What is the transformation that took place? And you would say, oh, that's a reflection in the x-axis. It crossed the x-axis. Okay? Good. So now we're going to reflect two figures. This one we're going to reflect in the y-axis, and the next one in the x-axis. So draw the original and reflect it. Okay, so we can plot these points. The first one, J, is at 0, 1. Oops, that's the wrong place. Box 0, fly 1. Okay. Then we have K at 0, 4. We have L at 5, 4. And M is at 5, 1. So when you connect these vertices, you see the shape? And I'm sure you can be even neater on your paper. So the next step would be to say, how do these change going to the image? And we're reflecting in the y-axis. So does everyone recall what is changing? If we're going across the y-axis, which value becomes opposite?
X.
The x, right. So if you wanted to write that as a rule, you could go -x and keep the y value the same. -xy. Okay? Okay, so we did the math, changing all of our x values to the opposite. And now when you plot them, notice that 2 points stayed the same, right? And then L went -5, 4. And M went -5, 1. So when we connect this, have we reflected the figure across the y-axis? Yes, and we did it by changing the x values, not the y. Okay? Very interesting, okay? And the final is a triangle, so we're going to have to pause. There's not enough time for the video, but we'll bring you back the answer. Go ahead and do it. Right. So in this case, all of the y values became opposite, And that causes you to reflect across the x-axis.